Hi everyone, welcome back. We continue on this list. Lastly, we learned about KAZE and AKAZE descriptors. Today we are gonna start with a new one, which is MSER. And this MSER stands for Maximal Stable Extremal Regions. So this stands for that. Also in here, first of all, of course, there are many member functions and parameters like the others. And the main difference of this feature description, this is just focusing to the regions. The others were also focusing at the same time to the features, the corners, and some of them was also giving the descriptors. For example, we have a famous table in here. You see, hopefully from camera you can see from here. Here we already learned these three, and the MSER is the others. The type also you can see. These are the key point detector, the feature detectors. Also, some of them was giving us the descriptors to be able to compare the key points with each other. But this MSER only is a kind of a region detector. So this is the one of the measure different than these three which we already learned. And also scale invariant, only the GFTT doesn't have. The others also MSER also have the scale invariant. But the rotation invariant, since this is somehow is not good to compare for the ones which doesn't give us the descriptors, because if it can give, if any feature description method can give us the descriptor, then we can tell its rotation invariant or not. Since this is not giving us a descriptor, so we cannot, of course, we cannot say this is rotation invariant. Also, the feature type, these are multi-scale robust key points, and some of them just binary descriptors, and this is only regions. Also, blobs like structures, we are also in the example we are gonna focus on the blobs. And the descriptor support, as I said, all of them. The actually in this feature description classes, the major thing, they are giving us descriptor or not. Also, they are focusing to the key point, or they are focusing to the regions. These two things are the major things we need to compare. So just keep in mind. And this MSER like this. So we already updated our table. Then after that, we can switch to the code part. Also, previously for the key point detections, we were checking this simple example. So we were trying to understand our examples via on this image. But now I changed my image for the region. So this I just got from Learn OpenCV website, and here we already have some blobs. So our target is gonna be detecting these blobs. Blobs are also kind of regions, so it's okay. We are trying to detect these things. And I want to, of course, code from the scratch just to understand. So first of all, simply we need to create our image, and all we need to do is just calling imread, and here we are gonna copy our image. Also, this MSER also you can give one channel, also 3 channel images, but I'm gonna make a warning in there. First of all, we can try maybe just with 3 channel images. And also I want to create a name window to be able to see to be able to resize the window easily. And here I'm gonna call frame maybe, or just call it result, and just make it normal window, and just show and result and my image, and that's all. Then make wait key. Oops. Okay, and that's all. This is gonna give me just the image. Now we can create our MSER object via on the PTR again. So all we need to do is just calling MSER, and here we can call our just MSER maybe, oops, is equal to, just like we did for the others, just create. And here we can, in this video we are just gonna learn about how this looks like, and we are gonna use the default parameters, so we don't need to create the parameters at the beginning. So in the next video we are gonna focus to the parameters just like we did in the previous videos. Okay, the next is we can directly call our detect regions function. Here we need to give our image as input, and also we need some kind of vectors for the So this is not only giving us the region boxes, I mean, for example, we are gonna, at the end we are expecting with this class, it's gonna give us a detected rectangle around the blobs, around the regions, but at the same time it's gonna give us the point belonging to that blob, to that region, so we can mask it. Also at the same time we are gonna be able to minimum rectangle which is surrounding our region. So we are expecting this class to give us two different purpose of the result. Okay, and so we need to create it. I need to just standard vector and one more vector of vector, and this is gonna be the point, and this is gonna be my points, and the next is gonna be also I need a one more vector for my boxes, for my surrounding rectangles. So this is gonna be the what was that? So I'm gonna give the points, and because of this it's not showing me, so I want to see, I don't want to give it wrong, so rectangle of the box. Okay, oops, rectangle, and this is gonna be my boxes. Oops, and I think I'm done here, so everything seems okay. So at the end we are gonna get our points and the boxes, but first of all I want to draw only my boxes, and here we can make a simple loop for which is gonna give me rectangle for each, maybe just call it rect, or r is okay, for each boxes, and here we can reach them, and simply we just call rectangle, and image and r, just make it yellow, which is our favorite color, and thickness is 2 is okay, and we are done. Let's try to run it. You see here there is only one is detected. Actually do not now first of all do not focus to the accuracy. I mean, of course I will also touch to another point, but for the accuracy maybe in the next video we are gonna play with the parameters, so maybe we can get a better surrounding rectangle for this blob. But at least even for with the default parameters, it's not expected, it's not okay, we are not detecting the others. Why is reasoning? Of course the parameters also in a reason, but this is suggested according to my experiences. Also just put this MSER or use this one with a grayscale images. So if I just simply make it of grayscale the input, so now but of course yeah, anyway, so yellow is not working, so maybe at the beginning I need to clone just to be able to visualize. Just call it output is equal to image.clone, and here I'm gonna use this output just for drawing my rectangles, and I'm gonna see that at the end. Oops, output image, oh, I'm reading with the, so here I need to just calling convert color and image to image, which is gonna be color BGR to gray. Okay, so now it should work fine. So I just want to see colorful. Oh, now also it's, yeah, at least now with the grayscale input it's giving me correctly all the, yeah, at least it's for each blob I have a rectangle around, even some of them is multiple, or we make it one, or to see, because some blobs are really small. But anyway, yeah, some is surrounded many. This is about the parameters, but you see the difference, right? If we give the 3-channel image we get only one blob, but if you make it grayscale it's working better. So this is sometimes happening like this. There is no really a logical explanation to this. Just keep in mind, just this MSER is working fine with the 1-channel images. And this was the bounding rectangles, and I want to remove this because we need to see it differently. And the next I want to see my points, see my regions, how it looks like. So simply we can call the row counters. We already learned this function. We already have a video about it, so we can call the row counters. And here we need to call output, and the next is the contours, which is we can put our points. And the next, if you make the -1, it's gonna draw at all, and the color can be yellow again. And the next is, or 1 is okay, thickness, and nothing else. Let's see how it looks like. Now you see the blobs are looks like this. So maybe we can see from here. You see the regions are drawn, at least for me it's fine. So it's detecting value, you see, right? This is even. So kind of it's giving mask. It's not directly giving me the contour around the shape, but at least you can get your masks. This is very good. So this MSER for this image, maybe simple image, but you can try with the others. Since now we are learning, we need to use a simple image. And this is the contour side, and there is the region side. There are two parts of this MSER, and in this video simply we just learned how to initialize, what are the differences with the others we learned before previously, and yeah, we learned to use at the beginning. And in the next video we are gonna focus into the detail of these member functions, these parameters, what are these for. Okay, I am done for this video. Thanks for watching. See you in the next video.